Hello everyone, we are group number 32. I am Aneesh Bajwa, joined here by my teammates Pranav, Yogesh, Mahajan, Keshav, Rohit Jaiswal and Nandani Bansal. We are very thankful for the guidance of our mentors Dr. Geetika Dua and Dr. Amanpreet Kaur on our capstone project titled Infrared Machine Vision for Detection and Classification of Defects Present in Solid Materials.
In our project, we have employed non-destructive testing techniques. These are evaluation techniques that have wide range of applications from constructions, aerospace engineering, and also have an application in the medical industry. Destructive techniques and invasive methods often damage the useful and viable parts of the materials that are being evaluated. NDT, non-destructive testing, and frequency modulated thermal wave imaging (FMTWI) are testing techniques, and they are effective because they do not alter the integrity of the material that is being evaluated. Pulse thermography, being fast and simple, remains one of the popular non-destructive evaluation techniques, though it has some limitations. In FMTWI, heating waveform relations are adjusted over a bandwidth B such that a chirp that is fully modulated, frequency modulated signal of duration T with much reduced peak power is produced. It can be produced by matched filtering, that is pulse compression, to improve sensitivity. In our project, we combine thermal wave imaging and machine learning for a fast and accurate way to detect and classify the subsurface defects in a solid material.
For our project, we are using a dataset of COMSOL simulation consisting of 2500 frames. The first step was to find out the suitable frame for applying watershed algorithm, by which we can count the number of defects present in the image. In the next step, we try to find a relationship widths and depths, and another relationship between peak shifts and depths of these defects. And the next part was to detect the defects in the image using a neural network based model. So for calculating the relationships between the depths and the peak widths or peak shifts, we used a image consisting of 6 rows, each containing defects of either air, water or oil. And we calculated a relationship between the peak width as well as the peak shift versus the depths of each defect. And here we are showing the equation for the defects containing water. Similar calculations were done for defects containing air and oil. And after calculating the peak shifts, we found out that the peak shift of air was significantly higher than the peak shifts of oil, followed by the peak shifts of water containing defects. So by this, we can classify that there is either air, oil, or water inside the defects. So for defect detection using neural network based model, we created the database of images, each having 27 cross 18 dimensions, and then pass them through a Gabor filter and use this Gabor filter response to train our. So the neural network that we are using is a simple single layer network, and the performance parameter that we are using for training is mean squared error. After training the model, we are testing it on an image having 9 defects. In testing, the first step that it do is to find the most potential areas where there may be defects present inside the image. For this, we are doing convolution with an image containing only a single image of defect, and the reasons where there may be defects present is represented by this yellow dot, and the reason around this yellow dot is then fed into a neural network, and the neural network shows the results as green if there may be a defect present, red that means there is no defect present, and if the output is blue colored, that means there is definitely a defect present at this position. So these are the results. So that is for our capstone project. Thank you very much.